Today I am going to discuss reaction mechanism of anhydrides. Anhydrides undergo nucleophilic substitution reaction. Anhydrides undergo nucleophilic substitution reaction. In this lesson we are going to learn reaction mechanism of symmetric anhydride and asymmetric anhydride. So let's begin. Reaction mechanism of symmetric anhydride. Symmetric anhydride. This is a kind of symmetric anhydride. Acetic anhydride or ethanoic anhydride. This is symmetric anhydride because this functional group carbon and this functional group carbon, both the carbon atoms are linked up with same alkyl group, methyl alkyl group. Based on this point, this anhydride is a kind of symmetric anhydride. To know the mechanism of anhydrides reaction, symmetric anhydride, ethanoic anhydride is treated with ammonia and the reaction is operated by heating. Simply splitting of ammonia, dissociation of ammonia can be shown in this way. This is azanide ion and proton. Dissociation of ammonia, splitting of ammonia simply in this way can be shown. During reaction mechanism, this matter will be clarified. When symmetric anhydride is treated with ammonia, then nucleophile, for example like this, and this is proton, this carbon becomes partially positive in charge because electronegativity of oxygen is higher than carbon. Carbon's electronegativity is 2.5, oxygen's electronegativity is 3.5. That is why this functional group carbon becomes positive in charge. Similarly, this functional group carbon becomes positive in charge. Because of this positivity, azanide ion, nucleophile, will attack this carbon or this carbon because this is a kind of symmetric anhydride. When negative ion attacks this carbon, then let us see what products are formed. When negative ion attacks this carbon, then this oxygen carbon bond experiences heterolysis. As a result, this oxygen becomes negative in charge. At that time, this oxygen is attacked by positive ion, hydrogen ion. As a result, this is obtained. Here, CH3O with this carbon, azanide ion, that is NH2 plus with this oxygen, this hydrogen atom, hydrogen ion, that is we got ethanamide and acetic acid. This is ethanamide and this one is acetic acid. Here we know that this is a kind of symmetric anhydride. Now let us see why this anhydride is symmetric anhydride. Suppose this ion, negative ion, attacks this carbon, then this carbon oxygen bond suffers heterolysis. As a result, this oxygen becomes negative in charge, and at that time this proton combines with this oxygen. Then let us see what products are formed. From this portion we get CH3, CO, with this carbon we will get OH plus. With this carbon we are getting this group, this portion, then CO, CH3. That is, we got acetic acid, and this is ethanamide. So in both cases we got ethanamide and acetic acid. Here acetic acid and ethanamide. So we can say that this anhydride is a kind of symmetric anhydride, and that is why we are getting same type of compounds. Because this is symmetric anhydride, both the carbon atoms are same in chemical properties. Both the carbon atoms are attacked by nucleophile in a same fashion, same pattern. That is why we are getting same type of products, same type of compounds. Now let us see reaction mechanism of symmetric anhydride. Let us write this anhydride, symmetric anhydride. Ammonia. The reaction is operated by heating. In the first step, this carbon-oxygen bond is polarized. After polarization, this is formed. Oxygen becomes negative in charge, carbon becomes positive in charge. This positively charged carbon is attacked by nucleophile. This is neutral nucleophile. In this way, then we get this nitrogen forms coordinate covalent bond to this carbon. That is why this nitrogen becomes positive in charge. Now, because of this positive charge, this bond breaks in this way. Covalently bonded electrons turn into lone pair of electrons, and this hydrogen gets freed as proton. This proton combines with this oxygen. As a result, this is obtained. This is obtained. We know that the reaction is conducted by heating. As a result, this oxygen hydrogen bond shifts here to form carbon-oxygen double bond. At that time, this bond undergoes heterolytic fission. This hydrogen gets freed as proton. This proton combines with this negatively charged oxygen. As a result, we are getting this one, CH3, here carbon oxygen double bond, here NH2. This bond is broken, and with oxygen, hydrogen is bonded. Finally, we are getting this, that is ethanamide and acetic acid. Here, ammonia bonds to this carbon, and from this ammonia, this proton is separated. That is, ammonia is splitting in this way. Simply, this can be showed. Splitting of ammonia, azanide ion and proton. So this is the mechanism in which anhydride undergo nucleophilic substitution reaction. Here ammonia is entered as the nucleophile and acetate ion goes out as nucleophile. So nucleophilic substitution occurs here. This is the reaction mechanism of symmetric anhydride. Now let us see reaction mechanism of asymmetric anhydride. Reaction mechanism of asymmetric anhydride. Let us write one asymmetric anhydride. This is a kind of asymmetric anhydride because this carbon, functional group carbon, is bonded to methyl group, but this carbon is bonded to ethyl group. Based on this meta, it's a kind of asymmetric anhydride. Its name is acetic ethanoic anhydride. When this is treated with ammonia in presence of heating, ammonia splits in this way that we have learned already. Azanide ion and proton. Now let us see which carbon will be attacked by this azanide ion, negative ion. Here, this carbon becomes positive in charge. At the same time, this carbon becomes positive in charge because of the higher electronegativity of oxygen. But in this molecule, this carbon is bonded to methyl group, which is a kind of electron donating group. This carbon is bonded to ethyl group. This is also a kind of electron donating group, but electron donating capacity of ethyl group is higher than methyl group, because we know electron donating capacity increases with the increase of the size of the alkyl groups. Firstly methyl group, then ethyl group, then propyl group, and so on. So electron donating capacity increases with the bigger size of the alkyl groups. So ethyl group is higher electron donating group than methyl group. That is why this carbon is going to neutral. This carbon's positive charge density decreases a lot because here ethyl group is powerful electron donating group, but in this case its charge density is decreased, but not like this carbon. In this carbon, charge density decreases to a greater extent. In this carbon, charge density decreases to a lesser extent. That is why this carbon will be attacked by nucleophile. This carbon becomes much more responsive to the nucleophile than this carbon. High percentage of reactions occur here, but in this case less percentage of reactions occur here. So when nucleophile attacks this carbon, then we get here CH3, NH2, proton with this oxygen, because this bond undergoes heterolytic fission. That is, we got ethanamide, and this is ethanoic acid on priority basis. Basically, this reaction occurs high percentage of ethanamide and a high percentage of ethanoic acid are formed. But at this carbon, reaction occurs, though this is less in amount. When nucleophile attacks this carbon, then we get, when nucleophile attacks this carbon, this bond undergoes heterolytic fission. That is, nucleophile is attacking this carbon, this oxygen then is attacked by this proton, and we are getting this CH3, CO. Here this oxygen with this hydrogen, oxygen hydrogen plus this carbon with nucleophile H2N, CO, C2H5, that is acetic acid, and this is propanamide. Here this is ethanamide, this is propanoic acid. So basically this reaction occurs because this carbon, functional group carbon, is much more responsive to the nucleophile, but this reaction occurs in less amount because this carbon is less responsive to the nucleophile, because positive charge density on this carbon is decreased because of the powerful electron donating alkyl group. So basically this reaction occurs, not this reaction, or we can say that percentage of these compounds are higher but percentage of these compounds are lower. This is the reaction of asymmetric anhydride. Another asymmetric anhydride, this one. This is benzoic ethanoic anhydride. When this is treated with ammonia, on heating, this anhydride produces products in this way. Splitting of ammonia is simply like this: azanide ion and proton. Which carbon will be attacked by nucleophile? This carbon or this carbon? We know this carbon becomes positive in charge. At the same time, this carbon becomes positive in charge. But which carbon is much more responsive towards negative ion? Here, this carbon is bonded to methyl group. This carbon is bonded to phenyl group. We know alkyl group is a kind of electron donating group, but phenyl group is a kind of electron withdrawing group. This ring means movement of electrons. Due to the movement of electrons, phenyl group achieves electron withdrawing nature. So simply we can say that phenyl group is a kind of electron withdrawing group, but methyl group is a kind of electron donating group. So because of the phenyl group here, positive charge density of this carbon increases to a greater extent, but here positive charge density decreases because of the presence of methyl group. So this carbon is much more responsive to the nucleophile. So negative ion will attack this carbon. At the same time, this bond will experience heterolytic fission. Oxygen becomes negative in charge. Proton will combine with this oxygen. As a result, these compounds are formed: CH3, CO, with this carbon, oxygen, hydrogen, and here with this carbon, this group, H2N, CO, phenyl group. This is acetic acid and this is benzamide. Basically, this reaction occurs. Percentage of acetic acid and benzamide will be higher, but another reaction occurs at the same time. That is, this carbon will be attacked by negative ion to a smaller extent, and as a result, these compounds will be formed. With this carbon, NH2 group, plus at the time this bond will experience heterolytic fission. Oxygen will become negative in charge. Proton will attack this oxygen. Then we will get ethanamide, and here we will get oxygen with hydrogen. These compounds, that is, this is ethanamide and this one is benzoic acid. So in this case as well, there are two possibilities, but this one will get priority because here this carbon positive charge density becomes higher because of the presence of phenyl group. So concentration or percentage of benzamide will be higher and percentage of ethanamide will be lower. Basically, this reaction will occur for these asymmetric anhydride. This is all about reaction mechanism of anhydrides. Basically, symmetric anhydride and asymmetric anhydride. No more today. Thank you very much.